Welcome to Teacheetah FluidSIM series. In the previous video we discussed the actuators and basically covered the difference between single acting cylinder and double acting cylinder. Also we discussed how we basically can change the parameters for single acting cylinder and double acting cylinder within FluidSIM. In this video we are going to discuss valves with a special focus on directional control valves, and at the end of this session we will look at directional control valve inside FluidSIM, and we will design again a simple circuit in which we will have a 5x2 directional control valve which is going to be used for basically controlling a double acting cylinder. Okay, let's start. So in general, the main function of valves is to control the pressure or flow rate of pressure media. So how many different forms of valves exist? Basically we have 5 main categories of valves, including non-return valves, flow control valves, pressure control valves, directional control valves, and shut-off valves. So during this series we are going to cover all of these valves inside each of the session that we would have, but today the main focus is going to be on directional control valve. So what is the main role of directional control valve and how they can be used within a pneumatic or let's say electro-pneumatic circuits? So they can be used basically as input signaling elements, they can be used as processing elements, and also they can be used as control elements. Okay, so how directional control valves are basically working and what are the main functionality of these components within a pneumatic circuit? So directional control valve control the path of basically compressed air. So the direction of flow is indicated in general within a directional control valve by an arrow. Okay, so let me bring the pointer. So they can be actuated manually, mechanically, pneumatically, or even electrically. We already saw how many different forms of actuation that we can have for directional control valve when we are using the configurable one, and also we saw in basically FluidSIM that we have different forms of actuations that they are basically already designed, like directional control valve with mechanical actuation, pneumatically actuated, or let's say electrically actuated. So the main applications of directional control valves include connecting or shutting off the compressed air supply, retracting and advancing pneumatic drives. Okay, so let's see, let's basically look at a pneumatic circuit, right? In that pneumatic circuit we can have a directional control valve which is basically connecting a manifold, right, to a twin pressure valve, for example, right? And from that twin pressure valve we have the connection to a pneumatic actuation for another directional control valve, and this directional control valve is connected to the actuator. So the first one can basically shut off the air supply for the twin pressure valve, right? And the second directional control valve, right, can shut off basically the air path towards the actuator. So the first one, as you saw in here, is connecting or shutting off the compressed air supply within the system before the actuator, right? And the second one is basically retracting and advancing the pneumatic drives, which is going to be the single or double acting cylinder, and depending on the application it can be another type of actuation mechanism too. So if we say we have the directional control valve as a signaling element, so let's say we have it within a system as a signaling element, we can have like a roller level valve to detect the piston rod position of a cylinder. So that can be basically in the form of signaling, because it can detect the position, right, and then it sends out a signal to a directional control valve, and from there it is going to be a form of signaling. As a processing element, so what a directional control valve can do is redirecting or canceling signals depending on the signal input that is basically sent to that specific directional control valve, or the signal that directional control valve is receiving. As a control element, the directional control valve can deliver the required quantity of the air to match the power component requirement. So let's say we have an actuator, right? The directional control valve should be capable of providing the amount of air needed for that power supply unit within that system, or let's say power component that we have within the system. We can also categorize directional control valves based on functionality and method of actuation. Per functionality, we can say we have a 2x3, 3x2, 4x2, 4x3, 5x3 valve. So I'll discuss how we basically use these naming for a directional control valve. And also we can have the naming and the category per method of actuation, because we need a form of actuation for the directional control valve, right? Because that should be actuated. And those type of actuation can be in the form of manual type, mechanical type, pneumatic and hydraulic pilot signal type, solenoid type, or it can be basically considering like the combination of these types of actuation. So within a directional control valve, we can basically describe them by the following items: number of ports, or let's say opening that we have, or let's say ways, number of positions, method of actuation, and also method of return actuation, right? So how many positions that we have within that directional control valve. So that is an important thing which is going to be represented in the naming of that specific directional control valve. How many ports or ways we have for that specific directional control valve. Again, that is going to be basically used in naming and labeling of that directional control valve. And what is the method of actuation? Are we using, let's say, manual actuation? Are we using mechanical actuation or electrical actuation? And what is the return method? What is the method of basically returning the directional control valve to its normal position? Okay, so these are the things that we have to consider when we are choosing a directional control valve, and these are generally used for basically classifying directional control valve. Okay, when we are looking at directional control valve within pneumatic circuit, we can see like the symbols, and also we can see letters. Sometimes we see numbers too. So we have a standard based on ISO standard in which we see the numbers for a specific directional control valve, and we have the standard by letters, as you can see in here, in which P is representing the pressure port, T, R, E representing tank port, return port, and exhaust port, and we have A, B, C1, C2 which are representing working ports and actuator ports. And any of this square shape, if we observe them within a pneumatic circuit for a directional control valve, each of them is representing the position. Basically means this system, this directional control valve can have how many positions. If it has like one square in its symbol, it just can take one position. If it has two square, as you can see in here, it can have two position. And if it has like three square shape, as you see in here, it means that it can have three different possible positions. And the arrow basically representing the flow of air and the direction that flow can have. Okay, as you see here, we have a few of the symbols that are generally used within pneumatic circuit, and each of them representing a directional control valve that already exists, and you can go basically buy them for your specific application. For example, this one, you see we have two ports, right? Two ways basically. And for this specific part, right, we have two positions and two ports. And as you see in here, the first one is representing number of ports and the second one is representing number of positions. And if we want to call it, we call it 2x2 way directional control valves, which is normally open, because if we look at the right one, right, the right square in here, the direction of the flow is open, so we can pass the air in its normally open condition, right, in its initial condition. And if we look at this one, right, what we can observe in here, we have three ways. If we consider the beginning and ending each of these arrow as two ports, right, so it has two ports here, one port in here, and the same thing in the other side. But what is happening in here, because this is basically the normal condition, we can say it is normally closed, right? So it is 3x2 way directional control valve, normally closed one. And we can name the rest. As you can see in here, we have 3x2 normally open, we have 4x2, 5x2, and 5x3 directional control valve. So as I said, we have basically numbering system, so we can have one as the pressure port in ISO standard. For lettering system we use P. 2 or 4 is going to be considered as basically working lines, or we can use the lettering system which is going to be called A or B, and we have 3 or 5 which is going to be exhaust port. Now let's look at two examples in here. I have two short video that we can see how basically directional control valve works. The first one that we have in here is 2x2 two-way two position valve. Okay, so if we look at this video, let's start. You see at the beginning, because it's a normally open, right, directional control valve, the air is passing through pressure port to the working port, right? Once we basically push this switch, right, this system is going to be closed and we cannot pass any air through this pressure port, right? So at the beginning it was basically a normally open directional control valve, but if we apply that basically push button, right, this system is going to be closed and the air cannot pass through this pressure port to port A. And if you look at the left side, it is basically a spring return. So if you want to call it, it's a two-way, two-position valve, which is normally open, right? And it is basically a spring return and push button operated. And if you look at this one in this side, here we have a normally closed one, and this time we have three-way, two-position valve. Let's look at this short video here. So what we have at the beginning, the air cannot pass, right, because it's a normally closed, right? But after a while, after a few seconds, what we will observe in here, right, you see the pressure port, exhaust port, and basically the working port, right? If we push this button, right, so once we push this button, the air can pass through this pressure to working port, and from there we have the system working, right? And if we bring this to the initial position, what will happen is the air should pass through the exhaust. So that is a normally closed, a spring return, as you can see in here, push button operated directional control valve. Okay, let's look at the rest of symbols that we have. There are many forms of actuations. Generally, we consider push button lever operated, detent lever operated, as you can see here, foot pedal. Depending on the applications, right, we have different form of mechanical actuations, as you see in here, and you can find almost most of them inside the FluidSIM when you are designing a specific circuit. We have pneumatic actuation. We will see some circuits in which we are using pneumatic actuation for directional control valve. In the part of electro-pneumatic circuit, we will use electrical actuation. We will have single solenoid operation, for example, or double solenoid operation. And sometimes we can even have the combination of solenoid and manual override, right? So we will basically test all of these cases when we are designing different circuits. Okay, so we pretty much covered and basically briefly covered directional control valve, different forms of directional control valve that we can have, the symbols, the definitions, how we can call them, right? Now it's time to look at the other forms of directional control valves, different other forms of valves. And what we have basically, what is non-return valves, what is flow control valves, pressure sequence valves, and combinational valves. So let's just have a brief definition of non-return valves. In future, we'll design a circuit in which we will have a non-return valve. The main role of non-return valve is to allow a signal to basically flow through the device just in one direction. So in the other direction, the flow will be blocked. Okay. Flow control valves. The flow control valve in general is used to restrict or throttle the air in a particular direction with the aim of reducing the flow rate of the air, and from there we can control the signal flow. Pressure sequence valve. So we use it for three main purposes. The first one is pressure limiting, the second one is regulating, and the third one is the sequence. So pressure limiting valve in general are used to on the upstream side of the compressor to ensure the receiver pressure is limited. Pressure regulating valve keep the pressure constant respective to any pressure fluctuation in the system. Pressure sequence valve is used if a pressure dependent signal is required for advancing of a control system. So what is the application of combinational valve? Sometimes we need to have a certain applications and certain functionality that we cannot find it in the commercially available valves, right? Then based on the knowledge that we have from different valves, we can combine them and get a certain functionality, right? And one of the applications that already exists in the industry is time delay valve. That is basically a combinational valve, right? And combining different sort of valves, and from there we get basically the functionality of time delay valve. Okay, so that is basically an introduction to directional control valves, and also a brief, let's say, definition to different form of valves. In the next part of this video, I will design a simple again circuit, and from there we are going to look at a configurable directional control valve with 5-way 2 positions, and we are going to use it for controlling a double acting cylinder. Okay, as I said in the first part of this session, I'm going to design a circuit in which we have a double acting cylinder, and it's going to be controlled by a directional control valve which has 5-way and 2 positions. So in lab 1, if you remember, in the very first video, and if you watch that video, I recommend that to watch that video, because in that specific video we designed a circuit in which we had a directional control valve with 3 ways and 2 positions, and we were basically controlling a single acting cylinder over there. And in this video I'm going to design another, let's say, basic pneumatic circuit in which we have a directional control valve with 5-way and 2 positions, and instead of having a single acting cylinder we are going to have a double acting cylinder. If you are interested in basically understanding the difference between single acting cylinder and double acting cylinder, you can watch the video number 3 and number 2. Over there you can have a better understanding of the differences that we have basically between these two form of actuators. Let's design the circuit. So again, we are going to use the pneumatic module in here, and we need to basically use a few basic components. The first one is the actuators, and we are going to use a double acting cylinder. And for the supply elements, that is going to be the same as what we have in general for most of the pneumatic circuits, which is going to be supply element, which is the compressed air supply, right? The air service unit that we have, and then I'm going to bring a manifold, which is basically distributing the air between different components. Depending on the applications, we can have a circuit with many actuators, right, and a circuit with many directional control valves. In there, we need to distribute the air in the case of having many components, right? And this manifold helps us to have that power of distribution of the air with a basically equal amount of pressure. Okay, we won't have any sort of pressure fluctuation there in the best and ideal case. Okay, so what we have to do, we have the air service unit, we have the manifold. The other thing that we have to add in here is the directional control valve, and as I said, we are going to use a directional control valve which is configurable, and it has 5-way, right, and 2 positions. So I'm going to use this one. Okay, and the next step is basically connecting them all. So I'm going to connect this compressed air supply to this air service unit, and from this air service unit we are going to have filtered air which is going to be passed to this manifold, right? And from this manifold we are passing the air to this directional control valve, right? And then we are going to connect this directional control valve to this double acting cylinder, right? So we have the double acting cylinder now connected to the directional control valve, and you see we have 2 ports which has no connection, and they are going to be used as the terminator. So if we double click on them, we can just choose the exhaust for both of them, right, and the other one in here. Okay, so now we have the directional control valve connected to the manifold, connected to the directional control valve. It's time to configure it, right? So if we go inside, double click on it, and if you go to the configure valve, so the first one that I'm going to use is a sort of manual actuation, right? A sort of, let's say, push button. And then the other one for the other side is going to be a spring return. Just hit OK. So we have the actuation for the left and right side, right? And the very last step is basically adding the labels. So for this one, I'm going to put the label 0Z, and then here I'm going to put the label of 1Z. Over here we are going to have 1V1, right? And for the actuator, based on the standard that we have, we can call it 1A. Okay, so now the labelings is done. The next step is just starting the simulation to see what is happening here. If we start the simulation, right, so you see the air can pass and it goes inside this double acting cylinder, right? And as you see, it is in the fully retracted position, so the air goes there, right? And if I actuate this directional control valve in here, because it's a formal, let's say, push button, if I actuate it, right, the air will basically pass through this way, right, because it's going to be connected to this arrow, right? Air pass and goes inside, and from the other side, the air will be basically transferred to the exhaust that we have in here, right? So let's do the actuation again. You see the air passed there, and the spring return push the directional control valve to its initial position, right? But if I keep this push button in the active position, we will remain in the fully advanced position until I leave this push button, right? It returns back to its retracted position. So that is basically the difference that we can observe between the double acting cylinder and at the same time how a directional control valve, right, with 5-way can be connected to a double acting cylinder, right? Now let's basically change it a bit. Here we have a sort of push button. We can use detent form, right? So let's stop this simulation. Again, double clicking here. Okay, configure valve, and instead of this form of actuation, I'm going to use this one. Hit OK. Now if I do the simulation, start the simulation, and then if I push this one, right, you see that directional control valve will remain in its like actuated position, and it's because of this form of actuation. It's called detent actuation, and it's kind of clamped there, right? It will stay there until we basically actuate it again, and then it returns back to its initial position because of this spring. As you see, we have many forms of actuation inside FluidSIM and also in industry. As I said, depending on the applications that you are targeting and depending on the circuit that you are designing basically for a specific application, you should take care of basically the form of actuations that you are using for the directional control valve. So there are several types of directional control valves, and you have to choose it based on the applications that you are dealing with. Okay, we are done with this session. We basically covered the information related to directional control valves, how we basically name them, what are the difference between the different forms of directional control valves that we have, how they can help us within a pneumatic circuit. Also, we looked at a very basic circuit in which we had a 5-way 2-position circuits. Already saw the single acting form and 3-way 2 positions. Here we saw 5-way 2 positions. So if you are interested, you can watch the very first video related to this topic, and in there you can basically look at single acting cylinder and its connection with the 3-way 2-position valves. Thank you very much for watching this video. If you enjoyed, please subscribe our channel.